Thank you, Prof. Okay, it's nice to have our another trainer, Dr. Rubaiyat Ahsan. He is our alumni from Department of Economics, and currently he is lecturer of Department of Finance and Banking in Curtin University, Malaysia. So it's our pleasure to have Dr. Rubaiyat Ahsan with us. His presentation topic is application of Wavelet, Coherence, and Multivariate DCC-Garch to finance time series. So without further ado, I would like to request Dr. Rubaiyat Ahsan to start his session. Thank you.
Thank you, Brother Muhib. Can you hear me?
Yes, can hear clearly.
Okay, wait, I just let me change. Sorry, yeah. Okay, Bismillahirrahmanirrahim. Assalamu alaikum to everyone. So it's a great honor for me, really, to be invited as a guest speaker in this conference. Moreover, I want to share my limited knowledge on Wavelet and Garch today. So let's try, and thanks for inviting. Thanks to the organizing committee to invite me, and also thanks to the participant who just waiting to listen to this session. Okay, then let's start. Let's start with let me share my screen first. Huh? Just share. Is it clear?
Yes, doctor, it's clear.
Here, right? Okay. Let me start with the basics so that we can get the concept. Because my focus on application mode, rather focusing on theory, but I want to start with the theory so that you can get a good, I want to make your concept clear so that the rest thing you can catch up easily. Okay, let's start with the arch. Then we will go to the Garch, then we will go to the M-Garch DCC, right? So start with the arch. Okay. Okay, we know the time series. I mean, econometrics definitions are not that easy to understand. Let me read for you first, then I will explain later. Arch model suggests that the conditional variance of the residuals at time t depends on the squared residuals from the past period. And this is the equation. So I don't want to read anymore. Then let's read about Garch definition. Gush model suggests that the conditional variance term H depends both on past value of the stocks, which are captured by lag square residual terms, and on past value of H terms. The Garch model equation is presented in here. Okay, let's explain it in my words. What I understand. So about arch is I just try to draw a diagram that may help you. So here you can see the diagram, right? So the arch is, it means what's the volatility today will be the volatility tomorrow. Or I can say the volatility yesterday will be the volatility today, right? This is the concept of the Garch. So to define the Garch, so we have to rely on some parameters. So if we see if the Garch term, so it rely on arrow terms, or we can say innovation today, and the time series yesterday. I repeat, this is the causal diagram I create. Can you see the cursor, right? Is it visible? If I move the cursor, is it visible? Can you see the cursor?
Yes, Prof.
Yes.
Oh, yes.
Yes, it's visible.
Okay,
Yes,
okay.
it's visible.
Okay, so my concern is so the arch effect is rely on the arrow term today or innovation today and the time series yesterday. Okay, I repeat, the arrow term or innovation today or time series yesterday. This is the concept of arch, right? Arch one model. Okay, so why we go for Gush? So there is some issue with the arch, right? What is the issue now? I will explain. The issue with arch is, you see, I draw a diagram here. If you see the diagram here, so the arch is how can I say, is can model the volatility like this spike. You see the spike, this is called bursting, econometric term, it called bursting. So it's very comfortable to model these spikes. So, but if the time series is volatile and it just stay, it's not like that the spike is, say, if it's go up, then it stay for some day and then drop a bit, then drop again. So this sort of changes cannot captured by an arch model. That's why we bring the Gush model. So the Gush model can capture those changes. So if I see here that the diagram you can see here, if it is, say, if you talk about the sale of ice cream, say if it is too hot, so then the sale go up, then it continue going, I mean, it's selling very high for a few days, then it drop. So this sort of volatility can be captured by Gush, which is not captured by arch model. So that's why the arch come here. So what was the, now let me make you familiar with the terms. So what is the extension here? The extension here, the Gush 1.1 model here is the volatility, or we can say the volatility today is the innovation or arrow term today, right? Arrow term today plus, I mean, arrow term, I mean, if we want to explore the causal diagram, innovation or arrow term today, and it rely on time series yesterday and volatility yesterday. This part is incorporated here. It was not in arch model, but we incorporate this volatility yesterday into this model. So this is fundamentally different from the previous model. Here you see we bring a new term, I mean new how can I say, new, you can say term also, just to capture the volatility, right? So now I repeat again. So this will rely on arrow term today, time series yesterday, and volatility yesterday. So that's why the equation is like that. So you see so if we rewrite the equation, so you see there's a coefficient plus another coefficient. So this is the time series yesterday, you see T-1, right? Plus the beta, the volatility, or standard, I mean, this is a coefficient beta. So this sigma is a volatility, and that's the volatility yesterday, right? This is the equation, right? So we have to square it because, you know, the data we got sometimes negative, right? So we have to square it, right? So this is how it works. So I don't want to discuss more about it because I had to cover a lot of things, not only this arch Garch, we have to cover DCC-Garch. It's not about theory, it's about modeling. I will show you how to model. I'll take sample and I will model it, and I will show you how to model, how to apply the theory into the data. empirical data. So I stop here, then I will just highlight few things on DCC-Garch, which is our main concern today. Okay. Here you can see. So let me read the advantage or motivation of DCC model or DCC-Garch model. First advantage, I just read for you. Then I will explain in my words. Okay. DCC model is based within the family of Garch model. DCC allows for the analysis of time variation in both mean and variance equation, whereas rolling regressions and Kalman filters are intended to examine time varying relationship. DCC allows to look at how correlation changes over time. DCC approach follow Arch model solution to modeling the volatility, where more weight given to the recent past and less weight given to the long past observation. Another advantage, with the Garch model, one can pinpoint precisely the timing and nature of the possible changes in the time series co-movement. Finally, in addition to measuring and accounting for the volatility of the series, the correlation can be measured and predicted. Okay, this is there are many advantages. This is the field and more important. So you already see that. So it incorporates Kalman filter, rolling regression, right? So to capture the time varying relationship, and then it incorporates Arch model. So what Arch model works in, it gives more weight to the recent past and less weight to the long past, right? And there and it also can predict the correlation, which is very important for us, right? It can predict the correlation, and it also can predict the volatility. Okay, let's just show you some, so that it will be the advantage will be very visible to you. If I show this example. This table is taken from one of my paper where I use a Garch, and this is the output of that model. So if you see, this is a unconditional correlation. So here you may not be familiar with the ticker. This is the BC, BCB, BMYR. This is all about tickers. So this represents the Bloomberg Singapore bond, Bloomberg Malaysia bond, Bloomberg China bond. This. So we already know that the tickers, right? So we don't write this Bloomberg Malaysia bond index. Rather, we use it and we symbolize it, and we use the symbol which is the so BMYR, right? So I want to check the correlation between two indices. I want to check the correlation between the Singapore bond index and Malaysia bond index, right? So for example, so there are many indices here. I don't want to explore or don't want to go in detail. So there are two, if we want to compare these two indices, so I saw the correlation is here, right? So if we see, this is the correlation, right? If we just Singapore, and if this is the bond index, Malaysia bond index, Singapore. So this is a correlation. And this correlation is coming from 6 years data. So for the 6 years, I got this correlation. So what do you think? So this correlation is lasting for 5 years. What do you think? So in last year, it was that. In last year, it was that. No. That's why the dynamic conditional correlation come into the picture. So now I just switch to this is the DCC-Garch, where you can see the dynamics. That means the correlation changing over time. Each line you see, each line representing two series. Say if we talk about the blue one, this is Dow Jones Sukuk and the US bond index. right? So these two, if you just see Dow Jones Sukuk and US bond, if you see the correlation is very high in 2010, then it gone down in 2011, then it become negative in 2013, then it become positive again in 2014, right? So we can see the changes over time, which is not possible here. This is the advantage of this DCC-Garch in Garch. So it's very important. And you know, as investors, some are short-term investors, some are long-term investors. So for them, they don't need this thing. Wait, what happened? Oh, sorry, they don't need this thing. They need, say for example, someone is investing for 7 days or 10 days. So they need only, say someone is investing for 1 year. So they need only this. They don't need the whole thing. So this Gush can customize and which is very helpful for the investors. Okay, I don't want to spend more on that. This is same thing. It's about volatility. So we can also model the volatility. So same concept here. So rather it's static, it become dynamic, right? Same concept works also here. Okay. Okay. Then just to talk about with theory how this DCC works, because at least you should have some theoretical background. Otherwise, when I start using the software machine learning, you will be lost, because you know the machine learning is not easy. I'll try my best to explain. Okay, don't worry. So let me read the procedure. The estimation of Garch is broken into 2 stages. In first stage, univariate volatility parameters are estimated using Garch models for each of the variables. The second stage, the standardized residuals from the first stage are used as an inputs to estimate a time varying correlation matrix. This is the steps that we're going to use. Then we talk about, we just brief not that, because if the derivation is very long, I don't use those derivation. I also don't bring, because it will be I mean a big thing if I want to do it here. I just want to show you the main equations. So the mean equations and the mean equation and the variance equation. So if I can say the HT is the conditional covariance matrix, and the equation is HT equals to TT, RT, and DT. Then RT stands for K into K time varying correlation matrix. DT equals to K into K diagonal matrix of conditional. And the decomposition of HT allows separate specification of the conditional volatilities and conditional cross-asset return correlation. So you know that this is all about technical terms. If you don't have a strong background in math and statistics, you may have difficulty to catch those. So let's try. So I hope some of you can catch. Many of you can catch, I know, but it's not easy. So let's proceed with the equation. This is the variance equation, so which measures the volatility. So this equation, the sigma square t is unconditional variance. Lambda 1 and lambda 2 are asset specific volatility parameters, and the condition is it should be equals to 1. And this is the mean equation. So I will not discuss in detail about it. This is the mean equation. So what we're gonna do, we will use those equation in using software, using our language. Okay, so just keep these two things in your mind, right? We are after the volatility and the mean, right? So we have the equation we already know. So now we will implement. Okay, let's jump to the analysis part. Okay, is that clear to you? Any questions so far? Okay, right? Okay, any questions so far? No, right? Okay. Let me share the software. Okay, so I want to use R language. Why I want to use R language? Because it gives flexibility. So if you may say, okay, there are many softwares in you can see that views, microfade, many more. But the problem with these softwares are, first of all, you have to buy those, and if you want to use a cracked version, sometimes it's not work. And moreover, if you will get something in microfeed, you will not get that thing in views, or you will get something in views, you will not get that thing in microfeed. So you have to buy many softwares. And moreover, if a new technique or new packages, if new packages are coming, if someone is introducing new package, it will take a long time to incorporate those packages in the softwares. That's why I prefer machine learning. So I prefer R language, which is open source, is free. But the challenging part is you have to know the codes. Once you can just learn the coding, then the rest will be easier for you. So this is a main reason, and it has a lot of advantages. Say, I can use new packages, and I can also it gives you more flexibility and more functions, which is not possible in software. So let's see, let's explore it. So I will use today. I'm gonna use machine learning to show you how this Gush process works. But one thing you should know, it will take a lot of codes. Sorry for that. So, but you will learn new thing. Okay, let's see. Okay, let's see, and let's start. Okay. Brother Muhimila was asking about the data. So in UViews or other cases, other softwares, data, you have to download it from the secondary source. Then you have to put into the Excel. Then you have to do some cleaning, and then you have to do some changes. Say if it is a price, then you have to make it return, right? Because we in time series we use return data. I mean, if you work with the stock market, so we use return data. So, but this sort of things can be done using this software. So I will show you how to do that. So no need to download the data, no need to run Excel file. I mean, no need to preserve those data in Excel file. So everything can be done using this software. Let me show you. Before using this software, you have to install some packages. So what you're gonna do, I have to mention first. What I will use some package. Then I will upload data. Then I will model. I will start with the Univariate Garch. I will model the specification. Then I will do the estimation, model estimation. Then I will do the forecasting. Right. The same we will go for the multivariate Garch, or we can say DCC. I mean, within this multivariate Garch, I will use DCC function, and finally we will focus. Okay. So this is the thing I want to do in this software. So before that, you should know you have after downloading the R, try to download the latest version. So it gives you a lot of new things, so which will be very useful for you. Secondly, you have to install some packages. So the packages, you should know the name of those packages, and it's very easy. So if you just go to the install, write the package name, write it properly, and if you click install, it will be installed into the software. Okay, I already installed these 3 packages. I need these 3 packages to do this analysis. The first one is Quant Mode. Second one is RU-Garch. Third one is RM-Garch. These 3 packages I need to run this analysis. Okay, so let's after when you have, I have already those packages in my software. No need to install it again. What I'm gonna do, I just load those packages. How to load? I can just write the commands here, right? It's like a library. Say for example, when I show you library. Okay, open parentheses. Quant mode, close bracket in India. Oh, so there are 2 brackets, sorry. Yeah. So if I want to write one by one, so it will take a lot of time. So I already create a script. Okay, I already create, it's already loaded. The library is already loaded. I already create the script. So I will run from the script. It will be easier for you and for me also, because if I want to write the commands one by one, it will take another 1 hour to demonstrate this process. Okay, so I already create the scripts. It's a very big script. Don't worry, I will explain one by one, but I already write it and I will just run the course now. Okay. Okay, so how to run? I will show you. This is the, I put a cursor, click run, then put your cursor, click run. Then the last one, the RM-Garch. So 3 packages. The last package is RM-Garch. So I just click run. So the package already loaded in the software. The next thing, I will download the data directly. Not download, I will just bring the data into the software from secondary sources, right? Using command. Before that, I have to specify the dates. So you see the command here, start date equals to, this is the command here. So I give the start date is 2008. I mean, first January 2008. This is start date. End date is 31st December 2019. So I already mentioned the start date and end date. I just click run. Then I click run again. Okay. So this is, I already defined my dates. Okay. The next thing, I will use 3 time series: Apple, Google, and British Petroleum. Okay. So to get those data, I need this get symbols. This function, I need the get symbol. So, and you have to know the ticker. If you don't know the ticker, you cannot, it will not work. Say every indices, they have a ticker, or every stock it has a ticker. Sorry, it has a ticker. So you have to use that ticker and you have to know that ticker. Otherwise, it will not work. So for Apple, it's AAPL. For Google, it's GWG. For British Petroleum, it's BP. Okay. So first one, Apple is the get symbol. So I use the ticker, and the start date, end date, I already defined before. So I just run for Apple, you see, already there. Then run for Google. You see, already there. If you see here, data already loaded in the system. Okay, and showing the time frame also. Okay, the last we're gonna load is the British Petroleum. Just run. Okay, so it's already there, right? It's 3. Now I have to see what is inside. Okay, then we use this command head, then you use the ticker. So if I run it, you see, make it ticker. You see here is the same we got in the, if you go to the Yahoo, if you go to the investing.com, whatever, you have a string. So you got this thing. Okay, the close price, open price, adjusted close, right? We got this thing, right? So very easy. Just you write some command, you write some codes, right? And you got everything, right? It make your life very simple. Just you have to know how to do it. Okay? Okay, then proceed. Now we will see the charts. So before we start the analysis, what we see in time series, whether it is stationary or not. So to check that, we just use a chart, right? So we draw a chart. So you see here, to do the same thing, we use a command, which is a chart series. So chart series, the commands is very easy, you know, it is the things we are using daily days, the chart, right? Chart series, it's very simple, right? Command. So, and the ticker we're gonna use for Google. So I just use run, I use Google, and I see this is the output. You see, this is not stationary, right? Then run for Apple. Yeah, it's also not stationary, right? Then run for BP, British Petroleum. Also not, right? So what we're gonna do? We have to take first difference, or we should take the return data, right? So to take the return data is also very simple command. So this is the command. We just use R and use the ticker, and we just define the daily return. Then we write the ticker. So if you just run, you got the return. You see the return is here, and you run again for BP. Is here. Then you run again for Google, also here, right? You see now it's the return data is there. Okay. Now we can see, okay, let's see the histogram, what it shows. Okay, so this is a very simple command, hist, open a parenthesis, then write the return. Okay, click run. Should be okay. Then just this command is not working. Then we have to run the second one. Let's see if I run it like that. If just run it, yeah. If you see now, yeah, you see the return data is now stationary. So last time when we used the price data, we found that it was not stationary. But when we use the return data, you see now it's stationary, right? So we are confident, right? So we can proceed. Okay. Then the next step we're going to do is we have to create a frame. Why we creating a frame? Because we have to do it in advance, because we will now we are doing the univariate Garch. Now we're going to know the univariate Garch model, but later we will do multivariate Garch to analyze, to do the to construct the multivariate Garch. We need a frame, data frame. So that data frame we are creating now. So let's just create the frame. So let me just run those for, this is not for this purpose, it's for, because I cannot come again and run that again. So I just run it now. Later I will explain when I do the multivariate Garch. Yes, I need to run, just bear with me and run this course. Okay, done. So I already prepare for multivariate Garch. So I will explain later. So this part is very essential. Okay, that's why I do it in the early stage. Let's talk about the univariate Garch model. So univariate Garch model. So what we have to do? So we will work with one time series, right? So what the first thing we have to do? We have to use the U-Garch spec function. We have to use the U-Garch spec function, right? This is this, okay? So we have to define this. Before that, we want to see what is inside, because I mean, it has some default properties. We have to check the properties, what is inside, right? So let's see, we use this UGspec. Okay, we use this UGspec and we just run. Then now we're gonna see what is inside the spec. I mean, the spec is specification, because the specification, like mean model is a, what you're gonna use. You are using Garch 1.1. So is the mean model is constant or not? You will define that, right? So let me see the spec first. Run the spec. You see here, if I make it bigger, if you see the spec here, the spec is shows standard Garch 1.1, and the mean model is a female 1.1.1, right? So this is the by default specification, right? So we already, oops. Okay, this is by default specification. Okay, now in this specification, what is defined here? The mean model is about ARMA 1.1, and the Garch model, this standard Garch, right? It's a Garch 1.1. So here inside the Garch term 1, Garch term 1, right? So if you want, say, if you don't want this default specification, you have to change the specification. What are you gonna do, right? So from 1.1, I want to make it 0.0. The ARMA order, which is 1.1 before, I want to make it 0. Okay, so simply if you just write this code, right? The UGspec, Garch spec, so mean model. So the ARMA order, I just change it from 1.1 to 0.0. Okay, I just run. I just run. Okay, now I want to check. You see, before it was 1.1, now it become 0.0, right? This is how you can change, right? Okay. Then the next step is just bear with me, because it's a long process, so you have to be patient. So this Garch model is very popular and also very not used for time series only. I mean, not for finance economics, but also it's using in many cases, right? So, and it's getting very popular nowadays, and many extension is coming. So if you run it properly, it will be very beneficial for you. Okay. So now I will fit this. I mean, we know the specification. Now I will use the Apple data. I mean, I want to use the Apple time series, right? So I already defined everything, right? I defined the spec. Now I use the data, which is Apple data, right? So if I just run on Apple, okay, then if I see what is there, yeah, this is the model. Okay, this is the model. If you see here, standard Garch 1.1 mean model. So this is a 1.1 AR1 MA1. Okay. Oops. Oh, sorry. This is the specification. Sorry, not that one. Sorry. I just messed up. So this is the by default specification. Then we change it to 0.0. Based on this specification, I run using Apple data, and I got this output. So what we learn from this output? So if we can say for example, this is the coefficient, right? This is the coefficient for mean, right? This is the coefficient, and this is the alpha. Let me show you the equation. Otherwise, you'll be lost. Let me show you. Just bear with me. Yeah. So this is the return equation, right? I already show you, right? This is the volatility equation, right? So how the data I got from, the data I got from here, how to use those data? So let me copy this and I'll paste it here. So now how to use this data? So this is the mu, this is the mu. So this will, if say you are now building your own model, right? So you have to you have to write your own equation. How to do that? So you just copy, I just show you, you just copy, this is the equation, I just copied here. This is the main equation for your model, right? Plus error term. Then for volatility, I show you. So this is the omega. Oops, sorry. Omega here. Okay. Then alpha here. Okay. Then beta here. Okay. This is how it works. So you generate your own model and you have to write your own equation. This is how to do it, right? So it's not about the crunching numbers. You have to understand those things, how to use those numbers into properly into your model, right? So this is how I just show you. I cannot go in depth because so many things here. So here you can see the information criteria. So there are 4 methods. So you say it gives you a good indication about the model. So you should prefer simplistic model rather than going to complex model. And where the lower the value here, you use that method, right? Then we talk about the chunk box. Here it shows you the serial correlation. So if you see the hypothesis is no serial correlation, right? And we cannot reject the null hypothesis. That means there is no serial correlation there, right? Okay, this is extension version of this chunk box test. So here we can see is also showing that the model I just built, we can accept that model. I mean the values we got is significant, right? So then this is a lot of things. Then I just let you explore it, because if I do one by one, it's not possible to show the DCC-Garch, right? Okay, so this is how you should explore by yourself. Okay, let me just go back. Okay. Okay, then where we are here, right? We got the model. Now we can get 2 drawers. We can say 2 drawer of instruments. I mean, how can I say? It's about inside the model, there are so many parameters, right? And if we can divide those parameters into 2 parts, so this is one is called fit and another one is called model, right? Let me show you first. So at first we just see the model. If you just run the model, because I told you that you can get a lot of things here. You can explore more. You see here the model, you can get, this is the parameters in depth. If you see the fit, you can see, so you can get the coefficient, you can get the residuals, you can get the C var, conditional var, you can get the convergence, many things. It's huge. So maybe we don't need all those things. From these lot of parameters, we just want to see the coefficient, which is very important for us. Let's see. So to see that, you just use this command ugfit, right? This command, you just use it, and you see we got the coefficients. The coefficients, we just write it here, right? We got it directly from here, right? So then we can I need the residual square. So I want to see the residual square. Okay, if I just run this command, I see. Then I see the I got the residual square, and then I have to see the var. Okay, let me. Oops, sorry. So I want to see two things. One is var, the other one is residual square. Let me run the var first. Var, then I will want to see the residual square, which is very important for us, right? These two things. Then I want to plot. So better if you get the visual, it will be very easier to understand, right? So if I plot it, and second command, and you see, I got two things. I got the residuals, which is the black, and I got the var also. And I saw the var, right, is just following the residuals. So it's good. It's good, right? You see the var is moving with the residuals, right? So it's going up. So it's a good model, right? So this is I need, right? So you got a lot of options. From that option, you choose which you need, right? No need to choose everything, right? Who need something else, he will just grab that, right? Okay. Let's proceed. Now I will do the focusing. So the focusing part is very important because it's very challenging and it's very important, because if we cannot focus what is going on in next month, what's the point of using this model, right? So this is very important and crucial part. And focusing is not that easy. So maybe sometimes it's you have to try. You have to do trial and error. So let me show you the basic. Then you will just change the model, and you will select the best one. Okay. Let me show you how to do the focus. For focusing, we will use a command, and we
Excuse
use.
me, Dr. Rubaiyat.
Yes.
Sorry
Yes.
for interrupting. Can you please maximize your screen, because some of the participants, they are saying that they cannot see clearly.
Oh.
In the PowerPoint, is it in the PowerPoint? No, it is in the.
No, ma'am. It's in our language, so there is no way to maximize.
Oh.
In the PowerPoint, I can, but here, no way to do. So, is it clear now, or is it clear, or I need to change something?
Prof, if you tell the participants to double click in their screen, then it will be maximized. Then
Yeah, correct.
Yeah, thank you.
That's good. Yeah, that's a good idea. Thanks for the opinion.
Okay, please, participant, you can do just now.
Please just double click in the screen.
Yeah.
So, yeah.
Can I continue?
Yeah, thank you.
Okay, then the next step is the focusing part. What I found here, by using the default parameter, is not that suitable. I will show you, but you have to do it. You have to do trial and error, and you have to find the proper model for that. Let me do it first. So I'm going to use the UGUH function to do that. So this is the command. So UG4 is so this is the Gush focusing command, and I want to do a focus for next 10 days. Okay, so from today, not today, I mean, say for example, let's say we want to do for 10 days, next 10 days. So you will use this command. So I just run the command, and I have to see what's the output. You see, I get the focus for next 10 days, right? This is the numbers I can get. This is the variances. I make it bigger. See the variances, the sigma, and this is the return. Return is not that much. I mean, it's almost same. Nothing changed there, but the variance is changed. I mean, the sigma is changing over time, right? So this is a time, right? 1 day, 2nd day, 3rd day, 4th day, 5th day, right? Until 10 day. And this is changing. So to get a better picture, let me plot it for you. If I plot it, so you will get the trend. So it's uptrend or it's downtrend, you will get a good picture of that. Okay, let me plot it for you. Just use this command because I don't want to explain each command because each command has their own property and many more. So if I get into that, the session time will not cover. Okay, so then let's run it. And again, you want to see the plot. And if you see the plot, you see it's uptrend. So we assume next 10 days, the price will be higher. So it's uptrending. Okay, clear? So, okay. Then what we want to do, we want to take last observation, last 20 days observation. And based on that observation, I want to focus for next 10 days. Okay, so let's see how to do that. Okay, so if you just, at first I need to define the last 20 days. Let me just run the command. And then again, I have to specify the next 10 days. Then I have to fit. I have to just use the function. Then I will gonna plot it. And I will use color. The focus will be orange, and the normal, I mean the focus for last 10 days will be orange, and the focus for next 10 days upcoming, I mean ahead of 10, I mean we are focusing for 10 days, right? That 10 days will be green. Okay, let me just run this command. So if I show you the plot, you see here. So we are just getting something based on our past 10 days data. This is the focus, right? The green that I said to you. So the color you can define from the command. So I define it here. So this is the orange that focus from the previous 10 days. And from that, we got focus for next 10 days, which is showing in yellow color, right? This is how. So you should do a trial and error, and you can come up with a good model, right? So which can predict more. I mean, which will be more. It's showing some, but the peak is very high. It's very volatile at that time. So that's why the focus also not that. It tried to capture the changes, but still something need to improve, right? Okay, that's all about the univariate Garch. Now we're gonna jump into the multivariate Garch. Okay, which is our main focus. So we will use DCC, right? So I will not go in depth. So I will just run the command and I will come up with the output and I will explain out. Because if I want to explain one by one, I think I cannot cover it within my time, within my allocated time, right? So let me just use the multivariate Gush model, and I will incorporate DCC into here. So we have to, at first you have to use the specification, right? So we have to define the specification. So here we already defined. So we're gonna use 3. So Google, Apple, and BP. So we use this 3 time series. These 3 time series we will use to model. Use this data to model. Huh? So here, so that's why you see the replicate 3. You see the replicate terms come here, and there's 3. So, and the ARMA order is 1 and 1 1, right? So let me run the command. Then the ARMA order Then we have to use this mmult command. So I just run it. I don't want to explain that much. So then I specify, because I already specified, right, my model. Right now I will use the spec, and I will use the DCC order, which is 1, 1, and distribution will be normal distribution. So if I run it, okay, I already got the model, and now I want to fit the model. So now you see the data, this data that I had defined at the beginning. Remember, I defined it at the beginning. So I created a data frame. In that frame, these 3 returns are there. So I just use this data frame and I run my model, right? So run it. Okay. I run the model. Then I want to see the fit one. You see, this is the model I got. This is the same last one we did for univariate, right? Now we are doing for multivariate. Here you see we got Apple, BP, Google. So for each time series, the thing is same. The way we define the equation is the same, but the uncommon part is the DCC. You see the join. You see the join DCC A1, DCC B1. This is the thing we are after. So we already get this too. So I don't want to just explain in detail because I did in univariate model. Now I will explore more on DCC parameter, not DCC outputs. Let me show you, because this is more important. This is the thing that differentiate from static model, right? Because we are in a dynamic model. So how the dynamic model works, I will show you the features. So that's why I don't want to explore, because you already know, many of you already know this. Let me show you the dynamic conditional correlation. Let me show you first. Okay. Okay. Then let me get the covariance first. Covariance, then we will get the correlation, dynamic correlation. Then I want to see what is inside the correlation. If we see, you see that here, there will be around 3020 correlation inside this. What does it mean basically? I mean, it contains each day correlation. What was the correlation yesterday? What was the correlation day before yesterday? Like that. So it contains a lot of correlation every day, right? So for 3 time series. So I will explore, don't worry. So I just show you what it contains. Then let me run the. You see, this is overall. This is a static model, right? So you see the. Oops. What happened? You see here, this is the correlation. The correlation of the entire time series. Say we start from 2008 until 2019. For those entire time period, we got this correlation. The correlation with Apple with BP, correlation Apple with Google, we got this matrix, right? Clear, right? Okay, so we got this matrix. Now I will go a bit further. So I want cross correlation, not cross correlation. Cross correlation, we can define it later. We can say we want to combine 2 time series, and I want to see how these 2 time series react within the time. Let me show you. So if I just run this command, so here I will run for Google and BP. So I want to see how these 2 time series react over time. Okay, so this is a bivariate, we can say, right? So we want to see how these two series how can I say, goes reacts over time, right? So let me run it and let me plot. Okay, this is the output. You see, the thing I will show at the beginning, you see, the thing is here. So you can see the correlation from 2008 until 2019. So how it changes over time, everything is visible. It's not about a single number. It's about it's about a dynamic. How can I say? It's about daily numbers. So it has a lot of use. You know, it's not about that. If you want a short-term investors, you can focus on, say, for a short-term period. If you are a long-term investors, you can focus, say, if you invest for 3 years or 8 years. So you have this big how can I say, the big chart, so you can make your decision easily, right? And you can, because you know that when financial analysts, they rely on chart. So this chart is very useful because they read, sometimes they just, how can I say, you heard about the support, resistance, head, shoulder. So this is very useful for them. So this is a resistance, sorry, this is a support, this is a resistance, many more things. I don't want to explore more, but it is very useful, and it gives you a lot of view. Okay, so let me do it for other series, so it will be more clearer to you. Let me do it for 3 series. Just quickly, I just do it for you. Wait, I just do the same thing, but for the 3 series. If you see here, it's Apple with BP, Apple with Google, Apple with, BP with Google. Those are 3 things you got. Okay, so it's very useful. Okay, now our most challenging part is focus. Okay, let's do the focusing, which is more challenging, and which we are after. The more accurately or precisely you can focus, better for you. I mean, you can be efficient financial analyst. Okay, let's do it. So we used another function to focus. Okay, so this is a DCC focus. So we will focus for next 10 days. We run the code and we see what is inside. You see, this is the focus. So here, if I make it bigger. Okay, here you see, this is the first 2 days, it's the last 2 days. Because of the window is small, they give only 4 days. You see, the correlation we got, this is called unconditional correlation that we got. I'll just show you. Oops, sorry. I think it's lost. Okay, it's not done. Because as you remember, we already got the correlation before, right? So now we are forecasting the correlation matrix for next 10 days, right? This is the matrix we got, all right? So this is very useful. So you can get a full matrix of 3 time series, so you can see how it works, all right? So it's very good for a financial manager, so they can easily get the correlation, and they can decide based on these results. I mean, whether they should buy or they should sell or they should hold. Okay, So the next thing, we will go a bit advanced. Now this is a unconditional focusing. Now we will do conditional focusing. Okay, let me show you. I don't want to explore the commas anymore because you get tired. Just bear with me, huh? And then, so now this is the matrix. You know, this is row. This is the row and column that we define here. So this is for Apple and BP. This is for Apple and Google. So as per the row, if you can see this is the row and column, right? This is the matrix is based on row and column. So we just use this row and column and we will focus accordingly. So I will just do the focus, and this is for BP and Google. Run. Then I run for. I will do dynamic now, right? No more unconditional. I will do a conditional correlation. Okay. Then run. I run a few commands. Now I will just. I run the basic thing. Now I will show you the plot. So then if I just show you the number, so you will be confused. Let me show you the plot. So it should be more effective for you. Let me show you. There are many commands just to plot it. Let me plot it. So here, what is the logic inside? So I will use last 10 days and I will focus next 10 days. Rely on my last, sorry. Based on my last 20 days, I will focus next 10 days, right? So the things I will just put it inside. Let me do it, run. This is for Apple and BP. And this is the color. I will define orange. Okay, then I will do it for next pair. Let me just run quickly so that you can get the idea. So I already learned this. Each para is for each pair. So this para is for 2 time series, which is Apple and BP. Okay, and this para is for Apple and Google, and this para is for BP and Google, right? So I'm doing focusing. So I just I have to do it separately because I want to plot it, and which will be very effective for you. Okay, let me just copy it quickly. Okay, done. Okay, oops. Why is one supposed to be 3? Sorry, I have to run it again. Okay, let me do it again. Okay. This is a dynamic conditional correlation. So this is the past observation. This is the focus for next 10 days, right? So which is also uptrendy. It makes sense, right? As it is very volatile and it's going to is showing it's uptrendy. So the focus we got also uptrendy, right? This is for the Apple and the British Petroleum, right? So and the correlation is between this range. Okay, then I have to do it for. So I just make it quick because I'm running out of time. You see, this is for Apple and Google, right? Last time we saw the Apple and BP, right? Now this is Apple and Google. This is also uptrendy. So because it's very volatile, and that's why it's also showing that it's uptrendy. So it's the focus also following the trend and it's going up. Okay. And the last one I want to run. The last thing is here. So it's between BP and Google. So it's, you see there's a downtrend, the focus also downtrend. So it proved that, so that what was the concept of the Gush or arch Gush? The volatility today will be volatility tomorrow, right? So this is a proof of that model. So as it is a downtrend, so we hope the next couple of days will be in downtrend also. Okay, is that clear to you? Any questions so far? This is all about focus. Is it clear? I think this is this is all about DCC, and this is all about arch, Gush, and DCC-Garch. I covered how to construct a model, and then how to do focus, everything. I mean, just to from the for what a model requires: data transformation, then model specification, model building, and finally focusing. Everything for univariate and multivariate. I have covered the both. Okay, is that clear to you? Does that make sense? Any questions so far?
Okay, Dr. Thank you so much for your nice presentation and in-depth analysis. So from our audience, is there anyone who needs some query? Please ask directly, or if you want, you can write in the chat box. Anyone, any information or anything you want to know?
I supposed to present the wavelet also, but time don't permit me to proceed because there is up. If I will start wavelet, it will take around at least half an hour. At least half an hour. It could be more than 1 hour. So I think it will be too much. So I don't want to start wavelet because I'm supposed to do, but I'm sorry because of the time constraint. I exceed my time. So next time, next time I will try to explore the wavelet also.
Inshallah, we'll try to arrange another session, another time for that. So please, any respondent, any participant, do you have any question?
Yes, Assalamu alaikum.
Okay. Yes, please ask.
Thank you so much, Doctor, for the insightful presentation. It's full with energy and information. Really appreciate this. My question is just a request. If is it possible that we can get the slides and maybe with a video? Because I think with the slide and the video, it will be easier just for us to maybe practice and just get the concept right. Thank you.
Okay, brother, thank you for your query. Actually, we already mentioned several times that after we complete all the sessions, it's this series until 30th of this month. So then maybe we'll share the video link. And for the time being, if anyone want to re-watch the video, so as we are sharing the live in our faculty Facebook page, so you can check from there for now until we complete our all sessions. Okay, and that's why we are collecting your information like attendance, so that after this we can share you the link, inshallah.
Thank you.
Okay, thank you. And if no more questions, so I think we can finish this session. Is there anyone? Do you have any more question, please? Okay, I think no one here with any question. So before end of the session, I should remind some more issues. As we shared the evaluation form, please, your evaluation is very much important for us to know the problems or issues we need to improve in future. So please complete the session, and please complete the session only you attended or the session only completed. Like today, some of the participants, they already evaluated the future sessions. So we would like to request, if one session complete, then you just fill up the one evaluation. So you can just complete the form again after the session when we will have another session, inshallah. And for attendance, the same issue. We already found that some participants already completed their attendance for future session, future programs. So please, again, when you will attend the session, you only complete the form for the session you attended. Okay, so I think this is the guideline from our side. Actually, this is a very big program, and this is the first time I think we are organizing the workshop series, and it's on 4 days. So 9 presenters are there. So it's actually, as we are attending from different places in the world, so we have to accept the limitations, especially the connection or the technical issues. So we apologize for any of the inconvenience caused during this session or from the morning. And also in future, if we face any session, we will request everyone to give your support to complete these all sessions together. So